So today we are doing like a crash course on like everything log E exponential, that type of thing, including both derivatives and integration. So let me share my screen, get those notes pulled up. So random sidebar, properties of natural logs, derivatives and antiderivatives, same thing with E, and actually inverse trig we are going to do later. Coming up, so that's going to be deleted. Do is problem such. I don't remember what I called it, something to do with logs and e's. I'll get that figured out. Or actually do was, I don't even know. I'll fill those in appropriately. But anyway, lecture, here's lecture, calc lecture, logs and exponents linked. So part one is logarithmic properties. I'm just going to let you go ahead and read over those, pause the video, write them down. This is just kind of like if you need to reformat your answer, maybe you did an integration problem and then multiple choice answers don't match what you got. You got to remember that there are these properties of logs that we can use. So that's just kind of like a brief reminder that I threw in there for your own good. Part two, derivative of the natural log function. So the derivative of the natural log function, derivative of ln x, is 1 over x. And then when you are taking the derivative of something that ln of u, natural log of u, so pretty much anything other than just x, then your derivative is u prime over u. Okay, so we're going to do a few examples for this guy. So first up, we have the derivative of natural log of 2x, ln of 2x. So we're dealing with this here example. So we're going to let u equal 2x. Okay, so then we know that the derivative of this is going to be equal to u prime over u. And again, we know that u is 2x because we can just look at the format of our problem. So ln of 2x is going to equal u prime, which is 2 over u, which is 2x. And 2 over 2x is equal to 1 over x. That is the answer for our first example. Next up, we have the same sort of thing. We have the derivative of the natural log of x squared plus 1, which will be equal to u prime over u, where u is equal to x squared plus 1. And I know this is kind of confusing because we've been using u in terms of u substitution, but this is back to differentiation. So we are just using u as representing some function that's not just x, some function that's not just natural log of x. Natural log of u represents natural log of any other function that is not just an x. Okay, so u is x squared plus 1. Derivative will be u prime over u, which is equal to 2x over x squared plus 1. Answer for number 2. Number 3, we have the derivative d over dx of x times ln of x. So we got a little product rule action in here. So that's going to be first x times the derivative of the second, derivative of natural log of x is 1 over x, plus second ln of x times the derivative of the first, which is 1. So we're going to get x times 1 over x, which is just 1, plus ln of x. Answer for number 2. Or number 3. And then number 4, we have some chain rule action. We have the derivative of natural log of x, quantity cubed. So general power rule, we take our exponent, we bring it to the front 3 times the thing that's on the inside, ln of x, to the 1 decreased exponent, so 3 minus 1 is 2, times the derivative of the inside, derivative of natural log of x is 1 over x. So final answer for number 4, 3 times natural log of x squared times 1 over x. So I know that these look a little tricky, but hopefully this is helping you see that it might not be as hard as you think. Part 3, integration of natural log. So the integral of 1 over x is natural log of the absolute value of x plus c. And then if you have anything other than x, so you know u represents any function other than just x, then you'll have natural log absolute value of u plus c. So for instance, integral of 2 over x dx, I don't know why this is writing weird for me, is equal to, we can pull out that constant of 2, we can actually kind of cheat this and rewrite it as 2 times the integral of 1 over x dx. Integral of 1 over x is natural log absolute value of x, so the answer for this guy is going to be 2 ln absolute value of x plus c. 2 times the natural log of the absolute value of x plus c. Next up, we have the integral. So let me write the integral of 1 over 4x minus 1 dx. So this is where we're going to be using u substitution so that we can get to a point where we get the integral of 1 over u du, which we know would be equal to ln absolute value of u plus c. So in order to get there, we have to let u equal 4x minus 1, du is equal to 4 dx, dx equals du over 4. So we're going to have the integral of 1 over u times du over 4. That du over 4 indicates that there's a constant of 1/4 that we can pull out. So we'll have 1/4 times the integral of 1 over u du. And then we know that the integral of 1 over u du is equal to 1/4 ln absolute value of u plus c. And then we know that 1/4 ln absolute value of u was equal to 4x minus 1 plus c. Beautiful. And then number 3 is a little bit tricky there. The integral of 1 over x times ln of x dx. I want you guys to go ahead and try this one. So I know it's tricky and I'm throwing you into deep water here because we just learned u substitution, and then even newer than that, we're learning about the integration of absolute value. But I want you to give this one a shot and we will go over it in class time. So please pause the video, try that guy out, see where you get. Part 4, derivatives of the natural exponential function. So the derivative of e to the x is itself. So this is super cool. So the derivative of e to the x is just e to the x, as long as that x is just an x. When we have e to the u, then our derivative is e to the u times du over dx, where that du over dx represents the derivative of u. So whatever that u is in your e. So for example, we have the derivative of e to the 2x minus 1. So we know that u is equal to 2x minus 1. And the derivative will be equal to, right here, e to the u. Oh, sorry, that's the integral. And the derivative will be equal to e to the u times du over dx. Du over dx represents the derivative of this guy, which is 2. So we are going to have e to the u, which is, in fact, u is 2x minus 1, e to the u plus c, or times 2 plus c. So our final answer here is going to be, sorry, I lost my spot in my work. The derivative of e to the 2x, I don't think I wrote this one down. E to the 2x minus 1 is going to be 2e to the 2x minus 1 plus c. And then next up, we have e to the negative 3 over x. So again, we're going to have to let u equal negative 3 over x du, which we can write as negative 3x to negative 1. Du over dx, or the derivative of that, is going to be 3x to the negative 2, or 3 over x squared. So then the derivative d over dx of e to negative 3 over x equals, we know, e to the u times du over dx. So e to the negative 3 over x times 3 over x squared, which is going to be equal to e to the negative 3 over x times 3 over x squared. You could do some algebra with that, but I'm just going to actually just leave it as is. All right, moving on, integration rules for exponential functions. The integral of e to the x is also e to the x, and the integral of e to the u is e to the u plus c. Okay, so this is more kind of classic u sub e type problems, right? Because we want to take the integral, we want to get to the integral of e to the u du, because then we know the integral will be e to the u plus c. So we have to set up so that we get e to the u. Like, for instance, if we had the integral of e to the 3x plus 1 dx, u equals 3x plus 1, du equals 3x dx, dx equals du over 3, excuse me, The derivative is just 3 times dx. And then we can plug this back in. The integral of e to the u times dx, which is equal to du over 3. Du over 3 means we have a constant of 1/3 to pull out. 1/3 times the integral of e to the u du equals 1/3 e to the u plus c equals 1/3 e to the u is 3x plus 1 plus c. Final answer. And then I want you guys to go ahead and try number 2 for this guy. So the integral of 5x times e to the negative x squared. Again, you want it in integral of e to the u du. So this one seems confusing, but you're going to want to let u equal negative x squared. Okay. And then derivatives for bases other than e. So this is when we have a to the x, which is just, a number 2 to the x. And that derivative is going to be natural log of a times a to the x. And then we have a to the u. So that would be if, again, that u represents a function that's anything besides x. So this would be if we had like 2 to the 3x plus 8. That 3x plus 8 is not just an x. So our derivative now becomes ln a times a to the u times du over dx. Du over dx, again, represents the derivative of u. And then we have a couple more log derivatives as well. So 2 more examples here to quickly wrap up. First one, derivative of y equals 2 to the x. That follows this top rule right here. The derivative we know is going to be, so this is in the form of a to the x, where a is equal to 2. So our derivative is going to be y prime equals natural log of a, which is 2, times a to the x, which in this case is 2 to the x. Final answer, ln 2 times 2 to the x. Next one up, we have y equals 2 to the 3x. So in this case, we have a to the u, right? Where u is 3x du over dx, or the derivative of u is going to be 3. So when we plug that all in to get y prime, we're going to get ln of a, which is 2, ln of 2 times a to the u, 2 to the 3x, times du over dx, which is the derivative of u, which is 3. So your final answer is y prime equals 3 ln 2 times 2 to the 3x. So these ones seem confusing, but really they're just kind of fitting the puzzle pieces into these formulas for the equations, right? Like, okay, I have a to the u. What is my a? What is my u? And how can I plug it into the answer? And then just like remembering them, right? So memorizing these so that when you see them, you know automatically what the derivative is. But anyway, that is a quick little sidebar talking about exponentials, logs, that type of thing. We are going to do some inverse trig, and then we will get back to chapter 4 after this, slight break. But as usual, if you have any questions, let me know, and I will see you all in class.